For exercise 2, which is about Archimedes upthrust, determination of the intensity of an alcohol and material nature of S by making use of Archimedes upthrust. In order to determine the density of an alcohol, the following experiment is performed. A solid S is suspended from the same dynamometer in air, water, and alcohol, as shown in the adjacent figures 1, 2, and 3 respectively. Indicate what does the reading of the dynamometer in air represent and deduce the mass of S. The indication here, which is 80 Newton by the dynamometer, represents actually the real weight of the solid S. So this is written here. The indication 80 Newton represents the value of the real weight of S. Then the question is to deduce the mass of S. So now we have that the real weight is 18 Newton according to the relation W equal M times G. M is equal to W over G. 18 Newton over 10 Newton per kilograms is 0.8 kilograms. 2. When S is immersed completely, and here I have to draw your attention to this condition, that S is being completely immersed in water as shown in the adjacent figure in figure 2. In water of density 1000 kg per meter cube, here the density is given in the SI unit, the dynamometer changes its indication to give 7 Newton, which is a value less than the previous one. A, what does the indication of the dynamometer represent in this case? So this is actually no more the real weight of the solid S. It's actually called the apparent weight. B, calculate the magnitude F of the Archimedes upthrust exerted by the water on S. So 2A, 7 Newton is the value of the apparent weight of S in water. In B, when they asked us to calculate the Archimedes upthrust exerted by the liquid, which is the water in this case on S, we have to make use of the following formula, which says that F upthrust is equal real weight minus the apparent weight in this liquid. So it's 8 Newton minus 7 Newton, which is 1 in Newton. In part 2C, they asked for the volume of S, the total volume of the solid S. So, and the action verb here is to deduce. This means that we have to make use of the magnitude of the Archimedes upthrust exerted by water on S. In order to do so, we have to make use of the formula that relates the magnitude of the upthrust to the volume of the immersed part of the solid. The original formula says that F upthrust is equal to the density of the liquid times V immersed times G. But since in this case the solid is completely immersed, so V immersed is actually the volume of the solid as which they are asking for. And the liquid here is what? The water. So that's why I wrote density of the water instead of density of the liquid. And instead of V immersed, I substituted it by the total volume of the solid S. Doing the other substitutions, F upthrust is 1 Newton calculated in part 2B. Density of water is given 1000 kilograms per meter cube. V is the parameter we are looking for, and G is 10 newtons per kilograms. Of course, we are talking on Earth. Doing the calculations, we get that V equal to 0.0001 meter cube in the SI unit. And part 3, now S is completely immersed in alcohol. The dynamometer indicates 7.2 Newton in this case. So here the apparent weight of S in alcohol is different from that in water. This is because of course the Archimedes upthrust changes. Why does the Archimedes upthrust change between the water and the alcohol? Because simply it depends on the density of the liquid, and water and alcohol have different densities. So calculate the magnitude F prime, I called it in this case, of Archimedes upthrust exerted by the alcohol on S. F prime now is equal to the real weight minus the apparent weight of the S in alcohol, which is 18 Newton minus 7.2 Newton equals 0.18 Newton.